Hi guys, this is chapter 4, lesson 4.1, graphing equations in slope-intercept form. And so today we are going to be talking about y equals mx plus b. And when we see an equation like this, let me give you an example. How about y equals 2x plus 6? So notice that we have a number in place of an m and a number in place of a b, but we always have an x and we always have a y. And what this is going to tell us is this is a line and has some very specific information. This is probably the most useful form, and we get really fond of this because it tells us some very specific things. Right here, b is the same as the y-intercept. If you remember about direct variation equations, remember when we had y equals kx, there was no plus anything out here because it went through the origin at 0 and 0. And so if we have a number here, it just tells us it doesn't go through the origin. It goes through y at a different number. In this case, 6. 1, 2, 3, 4, 5, 6. It goes through here. I always seem to make my graphs just so short that they that I'm at the end of my line. Anyway, this number right here is the slope. So m is the slope. It tells us the rise over the run. And so we can use this number to go from the y-intercept and actually graph our line. And so in this case, I have made it really awkward because I'm at the top of my graph, but 2 over 1 is my slope. So I'm going to rise 2, 1, 2, and run 1. It puts me right here. So I'm going to do that backwards. I'm going to run backwards 1 and go down 2. So see, I just sort of replayed this. This is the same thing, rise 2, run 1. If I'm here, I could rise 2, run 1. You get the point. So let's go ahead and connect that. And it is something like this. I never really get my lines once they're straight. So something like that. All right. And so what kind of questions are they going to ask us? They're going to ask us to do what we just did, to graph a line. They're going to ask us to change something like this into slope-intercept form. This is something called standard form. Standard form is nice, but it doesn't give us a lot of easy information like slope-intercept form does. And we can change it. Let's say we want to get it to be y equals mx plus b. Instead, we're going to maybe subtract 3x from both sides, because that's how you get something to cancel on one side and appear on the other side. And then we could divide by 2 to get y all by itself. We have to divide every single piece by 2 so that we would have, watch what happens with the fractions. Negative 3 goes over a 2, and that's times x, plus the 6 goes over a 2. And we can simplify that if it's nice. We could say like y equals negative 3 halves x plus 3. And notice what our slope is here now. Instead of rising, we're going to go down 3, and then we're going to run 2. So rise over run, if the rise is negative, it actually means we're going down. So we're going to go down 3 and over 2, and we're going to start our graph at 3. So we could actually graph that real quick. And we're going to start at 3. Super easy. And we're going to go down 3, 1, 2, 3, and we're going to run 2. And we could do that again if we want. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And I'm going down because of that negative 3. I'm not even going to bother to straighten out that line because I know what happens. Just like that. All right, the other thing we're going to see is something like this. Graph y equals -3. We've already seen these before, but these are called constant functions. Because y always equals -3, all we have to do is to find that place. And 1, 2, 3, here's -3. Y always equals -3 no matter what x is, and so it's going to be a horizontal line. The same thing happens if I have, say, x equals, let's make it x equals 4. Oops, now that's y. Make sure it's x. 4, and if x equals 4, that's a vertical line that goes up and down through where x equals 4. Okay, that's called a constant function. It is constant. It's always the same, and they're itty-bitty equations. All right, the next thing we might be asked to do is to actually look at a graph and tell what the equation is. I'm looking on page 218. There's an example, and there's an equation, and it says which one of these equations goes with that line. And the first thing I would do is look at the y-intercept. I see that it's at 1, and I could pick A or I could pick C. The next thing, the line is going down, so it's going to have a negative slope. Both A and C have a negative slope. So I have to look at my slope, and if you look, I go down 1 and over 1, 2, 3. Down 1 and over 3 will be -1/3, so the answer would be C. I know I didn't show you that on the board, on my board, but hopefully you're following along in your book. Look at page 219, and let's look at something where it says write an equation of a line in slope-intercept form with the given slope and y-intercept. Number 1 says that our slope is 2 and our y-intercept is 4. Piece of cake if you know this. So if the slope is 2, we're going to plug it in here. We always have a y, we always have an x, but we always need an m and we always need a b. Y-intercept is 4. Okay, slope, y-intercept. It's as easy as that. Okay, I might ask you some of those in the ed puzzle. Like number 2. Number 5 says to graph it. So if I have -4x plus y equals 2, I can change this into slope-intercept form. I don't have to. I could find the x-intercept and the y-intercept, and that would be cool. But I could just go ahead and change this into slope-intercept form. A lot of us get really used to this and enjoy this. Once I've done that, then I can graph this. And I'm going to start at y equals 2. That's my y-intercept. And I'm going to rise 4 and run 1. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. And so my line is going to look something like that. All right, if you look at number 9, y equals -1 is a constant. What is that going to be? It's going to be a horizontal line. Look at number 10. 15y equals 3 is another constant. It's going to be y equals 3 over 15, or 1/5. And so we could graph that as a horizontal line also. If you look at number 11, we actually want to write the equation for this. Super easy, no problem. We're looking at the page, right? And I can see that the y-intercept is at 2. So we're just going to fill in this, mx plus b. The y-intercept is at 2. I need to know the slope. From that y-intercept is 2. If I go up 2, I will have to run 1, 2, 3. So I can rise 2 and run 3 and hit the line again. Rise 2, run 3 times x, keep the y. We're done. That's the equation for that. Isn't that cool? Number 13, it says you can't write an equation, but that's not really true. I would just call that x equals -2. It's a vertical line. It's not defined. The slope of it is not defined, but you can write that equation. It's funny, this book seems to be prejudiced against that. Not a problem. They're going to probably show you a lot more y equals horizontal lines. Let's see. Number 17, it says the slope is 5, the y-intercept is 8. So you could write an equation, y equals slope times x. Y-intercept is 8. And then we could graph it. No problem. We just need a graph. And some space, because I'm going to start at 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to rise 5 over 1. So it's rise 5. 1, 2, 3, 4, 5. Run 1. It's always the top of my graph. I'm going to do this backwards. If I go backwards 1, I'm going to drop 5. 1, 2, 3, 4, 5. You can always do that. Just don't get mixed up. And that's not a very straight line, but you get the right idea. If you already have an equation, you're just going to be looking for that y-intercept and that slope. And that looks like the meat of this lesson. I'll let you go practice it.